Welcome back. In this video, we'll learn how to write Python control structures, conditionals, loops, and functions. Let's first look at if statements. Notice a few things about the if statement. There's no parentheses around the condition, but the condition does end in a colon. The body of the if statement is indented. In fact, for all of the control structures we're going to look at, keep in mind that indented code indicates a block of code. Let's run the code. Now let's make a modification. Let's say the person didn't pass, and let's say that we accidentally had this second print at the wrong indent level. What we see is that it printed out good job even though the person didn't pass, which is not what we intended. Here we have an if else. Notice that everything lines up at the same indent level. Let's test the other case. We can also have nested ifs. The elif will have its own condition and end in a colon. A final else is optional. Python does not have a case or switch statement since the same functionality can be achieved with a nested if. The Python relational operators are the same as other languages, and the Boolean operators use the words and, or, not. Python also has built-in constants, true and false. For all other types, false will be 0 for any numeric type, or any empty object, or the built-in constant none. Everything else is true. In the first example in this code block, we could have said if flag == true, but that's not considered the Pythonic way of doing things. Likewise, in the second example, we could have said something like if string is not null. The idea is to not write more code than you need to. For practice, write an if elif statement to print cold if temperature is less than 60, good if temperature is less than 90, and hot if temperature is greater than equal to 90. I'd like you to pause the video, code that up, and then we'll discuss a solution. Here's one solution. Notice that we check the temperatures in order. We could have gone the other way as well. Either way, we get the same results. Let's look at a while statement. Again, the condition for stopping doesn't have parentheses around it, but it does have a colon at the end, and all of the statements line up in the body of the loop. Let's run it. Now watch what happens if I accidentally have this at the wrong indent level. I have an infinite loop which I can stop right here. Be careful about indents. Write a while loop to echo out the user input until the user enters an empty string. Here's one solution. I primed the variable user input just to have something in it so that this condition is true and we can fall into the body of the loop. We'll stay in the body of the loop until the user hits enter. Let's run the code. Let's write a for loop to do the same thing as this while loop. I'll insert a new block of code. We're going to use the range function. The range function takes 2 arguments with an optional third argument. Range will create a series of numbers from start to stop -1, going by 1 by default. In our case, we're going by -1. More commonly, we use a loop to iterate over objects that are iterable. For example, a list. We'll talk about lists in a later video. Now we just created a list kind of on the fly here in the square brackets. A list is an ordered sequence of objects, and they don't have to be of the same type. So this for-in construction will iterate over every element in the list and print it out. There's nothing special about the word item. I could replace it with another variable. I could also replace it with an underscore, which is sometimes used in Python as a throwaway variable we don't want to keep. We can create a list and assign it to a variable and then index it like this. Let's look at another example. Here I'm creating a list of 3 strings. I'm going to iterate over the list and each time print the first character of each item in the list. Notice that we can index strings with the same syntax we use to index the list. Sometimes we want to iterate over a list and also keep track of the index. We can do that with the built-in enumerate function in Python. So enumerate will return 2 objects in each iteration. One is the index and the other is the element. And this way we get to have our cake and eat it too. In Python, a function is defined starting with the keyword def for define, followed by its name and parameters. A colon must be at the end of the def line. A function can have many returns. It can simply return or it can return a value. And we call the function with its name and any parameters that might be there. Let's look at a longer example. I've named the function findFirst. It will find the alphabetically first string in a list of strings. So it iterates through all of the strings in the list and returns the one that's alphabetically first. We have a small list here, and we'll call the function on that list. There are a couple of things in this function that might have made you a little nervous. First of all, we assumed that names is going to be a list of strings, but we didn't check that in any way. And second, we assumed that there's something in it. Let's rewrite the function with a little bit better practices. Here we've checked if the argument that came in was indeed a list, and if not, we return with an error message. Then we check that the names list actually has something in it. This is better, but we still haven't done any documentation. The typical way to do documentation for a function is with a docstring. A docstring starts with triple quotes. It will have a very short statement starting with a verb that tells what the function does. It will describe the arguments, what it returns, and also show a sample run. Normally, I won't show this type of documentation in functions that I show you. I did it here just to give an example of how to write a docstring. You should write docstrings in code that you put on your GitHub that you want other people to see. Python programs are organized into modules. A module can be just a single program, or it can have many files, each containing different functions. Functions from one module can be imported into another. Each module has a global variable called main. The last 2 lines here are used to jumpstart the program. In this case, just calling the greet user function. So if this file were run as a standalone program, this would be main would be the name, and it would call the function. If, however, this file was imported into another file, this code would not execute. This example also shows how to get a system argument. We have to import sys, and sys.argv1 would be the argument. In this sample case here, it would be Karen. One last thing we should talk about is identifier names. Python identifiers begin with an upper or lowercase letter, followed by letters, digits, and underscores. Most style guides suggest the following. Underscore case is preferred over camel case for variables. Function names should start with a verb and a lowercase letter. And class names should be nouns and start with a capital letter. We'll talk about classes in a later video. You know enough Python now to write a significant program. I encourage you to take a program you've written in another language and rewrite it in Python. This will be really good practice in getting used to Python syntax. Here's a suggestion. Write a program in the IDE of your choice to input a string in a system argument. Then loop through the string, finding the number of letters E. There are more efficient ways to do this than the loop, but this will be good coding practice. We'll start the next video with a sample solution, so before moving on, you should code your own solution. Bye for now, and happy coding!